So on page 666, 667, you have some extra space there. So when solving identities or solving equations, sometimes we need to use identities. And with that, I've got some strategies here. We've already seen the first strategy, where we've tried to write an equation using only one trig function. And we're going to find out sometimes you have a trig function of sine theta and a trig function of sine 2 theta. That doesn't count as one trig function. It has to just be theta only. So we're going to get some with double angle identities that we're going to have to use. So how do we do that? Sometimes we use sine squared plus cos squared equals 1. Sometimes we use our other reciprocal functions. Sometimes we're going to use our double angle formulas. Another strategy that comes up, and I think this comes up on your take-home quiz, is sometimes you're going to have to factor out a common factor. So if you would have done the homework from section 7.2, there's some in the homework that dealt with that. And lastly, sometimes the best option is to change things to sine and cos, just like you would do in a proof, and then try to get rid of any fractions. I'm going to scroll down just a bit. I know you're not done yet. To our first question. So going through our strategies, the first strategy is, can you change things to all the same trig function? Well, the only thing I can change cotangent to is 1 over tan or cos over sine. I can't change it to just cos. And I can't change cos to just cotangent. So in this case, we can't change things to just one thing. So we might go to our final strategy and say, if I change everything to cos and sine, again, I can write equals here because we're solving. And we can work on both sides because we're solving. If you change everything to cos and sine and get rid of your fractions, multiply both sides by sine, we get our equation to this point. Again, you can change sine squared to 1 minus cos squared, but you can't change sine to 1 minus cos. So at this point, we have things in cos and sine, and we don't have things as a single trig function. But this is one where you're going to be tempted to do something. And the thing that you're going to be tempted to do is get rid of the coses. Can you see a way that I can get rid of cos? Can you see that if I divide both sides by cos, the cos would go away? And then we're down to one trig function, and everything is good. Okay? The problem with dividing and getting rid of something is that you're going to miss an answer. Anytime that you can divide to get rid of something, you're going to want to factor instead. I'm going to show you what I mean. If I make one side equal to 0 by subtracting cos on both sides, can you see that you can factor this? That there's a common factor. So anytime you're tempted, because right here you might be tempted to divide something to cancel it out, you're going to be better to factor instead. And so now that there's a common factor of cos, and I factor that cos theta out, what would I be left with in my first term? A 2 and a sine theta. What am I left with in my second term? It would just be a 1. And now we could get either cos of theta is equal to 0 or sine of theta is equal to 1/2. When is cos equal to 0? Pi over 2 and 3 pi over 2. When is sine theta equal to 1/2? Pi over 6 and 5 pi over 6. I'm going to do a quick check of my domain. It said between 0 and 2 pi, so we're good. Now, the danger of dividing by cos. Okay, I'm going to do it in red up here because people will be tempted to divide this side by cos and this side by cos. These will cancel out and you'll get 1. These will cancel out and you'll just have 2 sine theta. You will still get these 2 answers with sine theta. But you're going to miss these answers with cos theta. Because it's possible, and if you look at the equation, you can even see it. Can you see if cos is equal to 0, that the left side will be 0 and the right side would be 0? And 0 is equal to 0. What happens if we divide by cos? We might, without knowing, do something that's not allowed in math. We might divide by 0. And since 0 was one of our solutions, and this is an example of where that happens. So whenever you can divide by both sides by something, instead move things over to one side and make it equal to 0 and factor instead. All right, that's example 1. Example 2, now that we've learnt our double angle identities, you're going to get solve questions with double angle identities. The question is, when should I use a double angle identity and when should I do a multi-revolution question? So I've got some notes on that as well. So for multi-revolution, if the only trig function that you have in your equation is a double angle, like we have here with this solved questions, cos 2x minus root 3 over 2 equals 0, then you should solve it like a multi-revolution question. If you have a double angle and another trig function, so here I have a sine 2x and a sine x, then you should solve it using a double angle identity. For our multi-revolution one here, we could get cos 2x by itself by adding root 3 over 2 to both sides. And if our domain for 1x is between 0 and 2 pi, then our domain for 2x is twice around 0 to 4 pi. So going twice around, when is cos equal to root 3 over 2? Quadrant 1 and quadrant 4, what family? Pi over 6 and 11 pi over 6. That's the first time around. 13 pi over 6 and 23 pi over 6 would be the second time around. Then to solve for x, divide each of them by 2. And all of those answers are between 0 and 2 pi. So when the only thing you have is a double angle, it can be solved as a multi-revolution question. There are ways to solve it using substituting in your double angle formulas as well, but this is usually the easiest way. If, as we have in the second question, you have a double angle and another function, then it makes sense to change it to your double angle formula. Can you see here that you could divide both sides by sine to cancel them out? So what should we do instead? Factor. Move it over and factor. Make one side equal to 0. Factor out your sine. So when is sine equal to 0? Zero pi and 2 pi. Do we include all three of those? Look at our domain. Yes, we do, because 0 is included and so is 2 pi. When is cos x equal to half? pi over 3 and 5 pi over 3.